Hello everybody, this is Pre-Calculus Inequalities Part 2. Alright, so in this one we're going to learn how to solve inequalities without a graph. So in the last one we saw an inequality, for example, if we had like f of x is greater than 0, right? And here's our graph, right? And then our inequality goes like this. We want the intervals where it's above the line 0. And like right there wouldn't count, right? So the only one on this graph that's above 0 is going to be this part, right? Or let's say that our graph looked like that, right? And we have f of x is greater than 2. We would find the 2 line, and it would only be the values that were above 2, so everything from here over and everything on this side over, right? So it would be intervals. So you'd have negative infinity to whatever this number is. Let's say that's -5, right? And then you'd have whatever this number is. Let's say that's 3 to infinity. Are going to be your intervals. And that's what we learned last week, or in the last lesson. In this lesson, we're going to learn how to do that without using a graph. So there are some steps. There's 4 steps to solving inequalities like this. Step 1 is solve the equation f of x equals a, and a is just whatever you're greater than or equal to, right? Is a. Take all the solutions from step 1 along with plus and minus infinity and list them in order. Divide a number line with intervals, so we're going to make intervals with the endpoints from the list. And for each interval, choose one number from the interval. Any number will do. So if we had like negative infinity to 3, right, we could choose any number that's less than 3. So we could choose 0, or we could choose 1, or we could choose 2. We're going to substitute that back into the equation, the original inequality, and check to see if it's true. If it's true, then the interval from which the number is chosen is part of the solution. All right, so let's try an example. 2x minus 1 is less than 5. So I'll write that out. 2x minus 1 is less than 5. Let me double check and make sure I did that right. Down here, 2x minus 1 is less than 5. So step 1 is to just solve it like it was in a regular equation. So I'm going to say 2x minus 1 equals 5 plus 1 plus 1. I'm going to get 2x equals 6, divide by 2, and I get x equals 3. Okay, so my only solution for that is x equals 3. So I'm going to use negative infinity. So my intervals, that means that's the only time that is going to cross that line is right here when x is at 0.3, right? So I got to figure out, is it going to be there or there? Which one am I talking about? Above that line or below that line? Okay, so I've got the values that are negative infinity, everything below 3, up to 3, and then I got the values that are above that, so 3 to infinity. All right, so those are my 2 choices. So I'm going to pick a number from each of these intervals, and I'm going to substitute it back into there. So if I picked a number from negative infinity to 3, I could pick 0. It's right in between there, and 0 is always easy if you can use 0. For this one, I'll pick 5. It could be any number that is above 3. All right, for 0, if I fed 0 into here, I would say 2 times 0 instead of x minus 1 is less than 5. 2 times 0 is 0. Negative 1 is less than 5. That is correct, so this one checks out. Yes, that is a solution. All right, if I put 5 in there, 2 times 5, there's my x, 2 times x, right? Minus 1 is less than 5. 2 times 5 is 10 minus 1. 10 minus 1 is 9. 9 is less than 5. No, that is not true, so that means this one does not check out. So my answer is going to be negative infinity to 3. And that's the only solution that will work for that. All right, we'll try one that's a little harder. Erase all this. Almost got it. Okay. The next one's a little harder. We got x minus 3, x plus 4. So x minus 3 times x plus 4 times 2x minus 7 times 2 minus 6x is greater than or equal to 0. Okay, so when I factor this out, we know each one of these factors has to be equal to 0. So I would have x minus 3 equals 0. So I do plus 3, and I get x equals 3. So there's my first value. I'll list these up here. The next one would be x plus 4 equals 0. So minus 4, x equals negative 4. So negative 4 is on my list. The next one is 2x minus 7. Equals 0, so I do plus 7. 2x equals 7, divide by 2, divide by 2. So x equals 7 over 2, which is really 3 1/2. Half of 7, 3 1/2. The next one is 2 minus 6x equals 0, so I'll do minus 2, minus 2. Negative 6x equals negative 2. Divide by negative 6. These negatives cancel, and I get 1/3 when I reduce that. So the last one is 1/3. Okay, so now I just have to create my intervals out of that. Alright, so I'm going to have negative infinity first. Okay, and then I need my lowest number, which would be negative 4. Okay, and then I could go from negative 4 to 1/3. And then I could go from 1/3 to, I believe this is 3 1/2. Okay, so I could go from 1/3 to 3, and then from 3 to 3 1/2, or 7 over 2, and then from 7 over 2 to infinity. Alright, now I have to pick a number in between all these intervals. So for this one I'm going to go with negative 5, so it has to be anything that's lower than negative 4. Now I have to have something between negative 4 and 1/3. I'm going to pick 0. Now I need something between 1/3 and 3. I'm going to pick 1. Now I need numbers between 3 and 3 1/2. I'm going to say 3 and 1/4, which should be the same thing as 13 over 4. Okay, and then between 3 1/2 and infinity, so I'm going to say 4. Alright, now I got to plug that in there and see if it works. Now, it's saying that it's everything greater than or equal to 0, so if it's positive, it will work, right? We can't use any negative numbers because negative numbers are not greater than or equal to 0. Alright, so if I plug 5 in here, negative 5 minus 3, I'm going to get 8, okay, times negative 5 plus 4 would be negative 1. Oh, whoops, that's negative 8. Yep, negative 3. 5, negative 8, negative 1. Negative 5 times 2 would be negative 10. Minus 7 would be negative 17. And then 2 minus 6 times negative 5, which would be positive 30. So that would be positive 32. So that'll be positive 32. C. All right. So if we have a negative times a negative, we've got 3 negatives. So this is going to come out as negative, so that means this one does not work. So all we have to do, we don't even have to figure out what the solution is. We just got to check to see if it's going to be a negative or positive solution. Any solutions that are negative will not work. All right? Okay, next we'll go with this one. I'm going to sub in 0 because that's easy. So 0 minus 3 is negative 3. 0 plus 4 would be positive 4. 2 times 0 would be 0 minus 7, negative 7. 6, that would be 0, so that would be positive 2. These two negatives will cancel, and this will be a positive number, so yes, this one does work. Alright, next one, I'm going to sub in 1. Right here, so I chose 1. 1 minus 3 would be negative 2. 1 plus 4 would be positive 5. 1 times 2 would be 2 minus 7, that would be negative 5. And let's see, 1 times 6 is 6. 2 minus 6 would be negative 4. Alright, so we've got 3 negatives. That makes this negative. 2 of them cancel. We've got 1 left over. Negative numbers do not work, so that one's out. Okay, next number we're subbing in, a little bit harder. It's 13 and 1, or 3 and 1/4. So if I have 3 and 1/4 minus 3, I'm going to end up with 1/4. Alright, if I have 3 and 1/4 plus 4, 3 and 4, that'd be 7 and 1/4. Okay, if I have 2 times 3 and 1/4, that would be 6 and 1/2. Minus 7, that'd be negative 1/2. And then if I have 6 times 3 and 1/4, 6 over 1 times 3 and 1/4, the same thing as 13 over 4. 13 over 4, and I can cancel there, and I'll have 2, and I'll have 3, and 3 times 13 is 39 over 2, and that was negative, because this is negative 6. So I have, that would be negative 39 over 2. So 2 over, let's see, that would be the same thing as 4 over 2. Minus 39 over 2, that's going to be a negative 35 over 2. Okay, these two negatives are going to cancel, and I'm going to end up with all positives, so the answer will be positive, so yes, that one does work. Erase all this extra stuff here. And then the last one we have to feed in is 4. So if I put 4 minus 3, I'm going to get negative 1. 4 plus 4 would be positive 8. 4 times 2 would be 8 minus 7, that would be positive 1. And then 6 times 4 is negative 24. And positive 2 would be negative 22. See. 3. Oh, that would be positive 1. 4 minus 3. That means I only have one negative right here. The whole thing's negative. So I can't use that one. So our two intervals are negative 4 to 1/3 and 3 to 7 over 2. Now for this one, it is greater than or equal to, so we're going to use square brackets for that one. And that's it. Now what this is really talking about is if we had a graph that looked like that, and we've got all these points. So our first point, see, here's our negative infinity, and our first point would be negative 4 right there. So we would have this interval from negative 4 to negative infinity. Okay, then our next point is negative 4 to 1/3. Our next point is 3, and then we had 7 over 2, And then that was it. So let's see. Oh, it erased my whole line. Okay. So if my line went like that. Okay, so this one's negative infinity to negative 4. Negative, that's that interval. And then negative 4 to 1/3 would be that interval. And then 1/3 to 3 would be that interval. And then 3 to 7/4 would be that interval. And then from 7/4 to infinity would be that last interval. Right? And we're trying to figure out which ones are above the 0 line, greater than or equal to 0. And it turned out to be negative 4 and 1/3, this one right here, and 3 to 7/2, that one right there. All right, so that's really what you're trying to figure out with these, without a graph. I know it seems like a lot of steps, but once you get the hang of it, it's not so bad. On the homework for this, I'm going to have you type in your answers in a line, and you should be able to type them just fine. Just make sure you use square brackets if it's greater than or equal to, and rounded brackets if it's just greater than. Okay, so you're going to be writing it in interval notation with a comma in between the two numbers, and then make sure your bracket is either square or rounded, depending on if it's greater than or if it's greater than or equal to. Lesser than, use a round bracket. Lesser than or equal to, you'd use a square bracket. Okay, whoops, I think there is another example. Okay, this one. This one uses the absolute value of x squared minus 12. Okay, so I've got the absolute value of x squared minus 12 is less than 4. Okay, so we remember that when we're working with absolute value, we would do x squared minus 12 equals 4, and then we would do x squared minus 12 equals negative 4, because we have to count for all of the positives and the negatives. So first we solve this one, so we do plus 12 plus 12, and we get x squared equals 16, square root, both of those, square root of 16 is 4, or it could be negative 4, so it's plus or minus 4. This one we do plus 12 and plus 12, and that would be x squared equals 8, and so then we would need the square root of both of those, so x equals positive or negative square root of 8. All right, so our intervals are going to be negative infinity to, and this really comes out to, this is going to be between, see if we said 2 times 2 is 4, it's going to be somewhere between 2 and 3 times 3 is 9, and 9, somewhere in there between 2 and 3, right? Because it's between the square root of 4 and the square root of 9. So it's somewhere between 2 and 3. I think it's 2.88 something. I keep messing that up. Somewhere in between 2 and 3. Okay. All right. So negative infinity to the negative 4 will come first. And then we're going to have negative 4 to negative square root of 8. Because that would be negative 2 point something. And then we're going to have negative square root of 8 to positive square root of 8. And then our last one will be positive square root of 8 to infinity. Now let's get rid of all that. You should already know how to do that. We did that in the first chapter. Okay, so last one is positive square root of 8 to positive infinity. All right, so now I need to pick a number for each of these intervals and feed it back in and see if it works. So if I pick this one, I just need a number that is less than negative 4, so I'm going to say negative 5. And this one I need a number that is more than -4, but less than, I'm going to say -2, because I know that's more than 2, right? The square root of 8 is somewhere between 2 and 3. 3 is more than it, 2 is less than it, so I'm going to use, wait, if it's -2, I need to use -3. Will definitely be less than it. Okay. If it was -2.8 something, -3 would be less than -2.8. Yeah, that makes sense. Okay, and then this one, I'm going to use 0 because that's my negative and my positive. And then this one, I just need something that's more than 3. I'm going to say 4. Because that's 2 point something, something that's more than that. Alright, so I've got the absolute value of x squared minus 12 is less than 4. Now I'm going to plug -5 in there. So the absolute value of -5 times -5 would be positive 25 minus 12 is less than 4. 25 minus 12 would be 13. The absolute value of 13 is less than 4. Is that true? No, it is not true, so that one's out. Okay. This one I'm going to use -3. So -3 -3 squared minus 12 is less than 4. -3 squared would be 9, because it's -3 times -3 makes positive 9, minus 12 is less than 4. 9 minus 12 would be -3 is less than 4. Yes, -3 is less than 4. So that means that this one does work. -4 to the negative square root of 8. Alright, let's do the next one. Erase all that. And hopefully you guys are following along with your handout. Okay. So this next one is 0. Zeros are usually pretty easy. 0 squared is just going to be 0 minus 12. Absolute value of 12 is less than 4. Nope, that's not true, so that one's out. That one was pretty easy. Alright, and last one, we got to plug in 4. So 4 squared minus 12, absolute value of that is less than 4. 4 times 4 is 16 minus 12, which would be absolute value of 4. Right? Yep, is less than 4. 4 is less than 4. No, 4 is equal to 4. Actually, that I think works. Let's see, what if I use another number? So if you get one and you're not sure, just go a number higher. Alright, so what if instead of 4, I used anything bigger? If I could use 3, I could use 5. Let me use... Oh, I forgot an interval. That's what happened. I forgot an interval. I need that to be... I forgot my positive 4, right? Because I've got -4, negative square root of 8, positive square root of 8, and then I have positive 4. So I need the positive square root of 8 to positive 4. Then I would need 4 to infinity. Okay, so for this one, I'm going to use 3. I can't use 4 because 4's there. That's why it was coming out wonky. Alright, and then for this one, anything above 4, so I'll go with 5. Alright, so I need the absolute value of 3 squared minus 12 is less than 4. 3 squared is 9. 9 minus 12 would be negative 3 is less than 4, and that would just make, once it's the absolute value of negative 3, right, so it would be 3 is less than 4, and that is true, so this one does work. And then we'll try that last one, which is 5. So we need to square 5, subtract 12, and see if that's less than 4, which I don't think it's going to be. So 5 squared minus 12 is less than 4. That would be 25 minus 12. That's 2 is 3. 2 minus 1 is 1. Square root of 13 is less than 4. 13 is less than 4. No. So that one's out. So we've got two intervals, negative 4 and the negative square root of 8 and positive square root of 8, 4. So those are the places when it went up over 4, and these are the places when it dipped below, and then it went up over, and then it dipped below. Okay, and so that's the answer to that one. All right, are there any more practice ones? All right, warning. You can't choose an endpoint from the interval as your number to test. It must be a number from the interior of the interval. So none of your numbers that you have listed can you use to test. All right, that is all for part 2 of inequalities involving continuous functions.